Assalamualaikum and hello everyone. I am Murni Nur Izzati binti Harulizam with metric number 206681. In this video, we will be presenting our electric circuit analysis ECC 3115 project, which is automatic hall lighting systems. For our group presentation, we divided into 8 sections. The first one is team member, follow up with the objectives, introduction, components, circuit design and diagram, results, calculations, and lastly, conclusion. Before that, let me introduce my team members. Our group consists of 3 members, which is me, myself, Murni Nur Izzati, Seri Suriani, and NURUL Ainaa. The objectives of doing this project are to build an energy-saving automatic hall lighting system with integrated simple switch concept to reduce the amount of electricity needed to light a room and to reduce electricity costs. So, what is an automatic hall lighting system? In this application, we will observe that the light in the hall will automatically turn on or off by detecting the movement of doors, whether it is closed or open. Otherwise, the light will stay turned on until there is no motion of the door. There are 6 components that are used to build the circuit: capacitor, resistor, bulb, switch, 555 timer, and 741 operational amplifier. Now, allow me to illustrate the functions of 555 timer. This system is implemented using a microcontroller which uses a 555 timer as the heart of the system and sensor to detect the movement of the door. The 555 timer is a highly stable integrated circuit that can produce accurate time delays and oscillations. For our project design, we will see on the monostable timer IC. In monostable mode, the 555 timer outputs a single pulse of current for a certain length of time. Now, let's understand more about operational amplifier. The operational amplifier comparator works such that it compares one analog voltage with another analog voltage or commonly with a reference voltage and produce an output signal based on the voltage comparison.
This is the circuit design for our automatic hall light system. Our circuit consists of one power generator, one door, one bulb, 7 type of resistor, 2 type of capacitor, one IC 741 OP-AMP, and one IC for 555 timer. This is the circuit diagram for automatic hall light system that has been designed and built in the multi-sim software based on the circuit design before. So here the switch will act as a door, the IC741 operational amplifier will act as the comparator, the IC555 timer will operate as a monostable timer IC. When the switch is open, the inverting terminal is connected to the 12-volt supply and a voltage at approximately less than 4 volt is fed to the non-inverting terminal. From the calculation, the circuit is having a low voltage which is at approximately 3.265 volt. Thus, a low logic pulse was generated at the output of operational amplifier. Next, the low logic pulse was then fed to the timer IC input through a capacitive potential divider arrangement. The timer IC was triggered by the low logic input and generate a high logic pulse as it is output working in a monostable mode. Thus, the bar receives a now high voltage for it to go for a certain amount of time, which we obtain from the calculation is approximately to be 5.17 seconds. Since the non-inverting terminal of the OP-AMP is at a high voltage compared to the non-inverting terminal, the output of the OP-AMP is at a logic high. When the timer IC receives a high logic input, this will fail to trigger the timer. Thus, there will be no output from the timer, this causing the bulb to get off automatically. The result that we obtain by applying the concept to our project design: when a person comes to the hallway and opens the door, the switch will on and the light will automatically turn on. While a person that comes out from the hallway and closes the door, the switch will off, the light will automatically turn off at a certain length amount of time since there no detection of movement happened that time.
So I will continue the presentation. Okay, so this is the calculation that is involved in our project design. We integrated the resistance in parallel formula, and also we use some formula for the op amp. Right. So the first one is we find the R input for the connection 2 on the op amp, which is here. So our R input is 16,739.13 ohms, and for the second value that we find the RF connected to the F, which is connected to the connection 3, which is the feedback resistors. So that would be the 909.09 ohms, and with that two value, with the R input and the R feedback, we can find the gain for the amplifier using this formula. R feedback divided by R input, which is we got the value of 0.0543. So to find the V out of the op amplifier, we use this formula gain times with the V supply. So we have a V supply of 12 volts, and we multiply that with the gain value, which is 0.0543, and the V output is 0.6516. So this value will be used later in the 555 IC. For the 555 timer IC calculation, first we have to find the VI, so we know how much voltage that is needed to enter the timer IC 555. Timer IC 555 need a value less than 4 volt, thus it only receives low feed. So based on this diagram, we can see that our previous value of V output, we make a capacitance voltage division to find the value of V. So the value of V1 that we want is 3.265 volt, which is less than 4 volt. Thus, we are able to feed the IC timer 555 with the low input that is needed, so that the light bulb will light up. The second value for the timer IC is we find the approximate time for the lamp to be switched, or T. So using the formula, T is equal to 1.1, resistor 1, and capacitance 1. So the resistor 1 would be the 10K ohm, and the capacitor 1 is the 470 microfarad, and multiplying all those, you get 5.17 seconds for the value of T. So that is the value of T. So when the door is open, there will be approximately 5.17 seconds for the lamp to switch. Finally, I will go to the conclusion. So at the conclusion, this segment of project design helps us to understand better about how the 555 timer works today, and also how the op amplifier works as a comparator for feeding the low input signal that is needed for the 555 timer. We also learned that the importance of mathematic light system, which we can achieve by using basic circuit analysis method to our human daily life, which the first one, it reduces electricity bills, thus we only needed to light up the lamp when needed. It improves home security, which means that if a burglar were ever to open the door on our hallway, we would know immediately, because our light will automatically if we turn on, and it also helps with the conservation of the energy in our home. So that's it from our group.